then down converted, right? And then here is RFG. Okay. Yeah, I don't know if this is done back. So this in practice, what happened is, okay, so let's just say I had a, okay, suppose that in pass band, RPFT, I should say, sorry. Is equal to alpha times like this. Okay, so let's say it was channel like this. All right, what is
Is it something more likely, like we'll get on the test?
yeah. But this is, you have to review, I have to give you the formulas because I don't really expect that you remember all the baseband transmission formulas from this was like the very first exam. So this part I would expect that you could get. So what is the transfer function for delay?
Just a question about the formulas that you'll be giving us. So are you going to be included in the question, or are you saying you're going to provide a separate formula sheet?
I'll give you them in the question. Any question, anything that you would need like that. So what's the transfer function for this system? Do you guys remember?
Oh, it's just a delay, like it's
A delay.
alpha S P of F
Yeah, it's alpha E to the minus
to the minus.
2 pi F tau. All right. Okay, because it's.
Then we have to
J.
put S of P of F?
What's that?
Do we have to put S of P of F?
No, just no. That is just a ratio of R of P over S of P.
Oh,
Okay. Does that remember? Do you guys remember this? From
Yeah.
no. I'm seeing a no. Okay. So if you just what's the impulse response for this system? If I just delay it. Yeah, but delayed impulse, right? So what is it? It's G of T is what? It's alpha times delta of T minus tau.
yeah.
Right? And what's the Fourier transform of delta of t?
E to the minus.
It's 1. Yeah, it's 1. And then delta of t minus tau is just shifted.
Yeah, E to the minus.
Okay. Does that make sense now? Okay. So what is the effective baseband? So a lot of this stuff is just like finding effective channels of each other. So that is IEG of F is equal to R of F over S of F. So I would probably give you this equation, all right? Remember that that's just G, because if I wouldn't have given you this equation on the first midterm, but you remember what you do is you just shift the thing to the left, all right? So you just take this guy here. The reality is I forget these equations. All right, so this guy here, you should know that there's a channel. All right, you should know that there's a channel, but you just find to look it up. Okay. So that guy's what? That is just going to be alpha times e to the 2 pi j f of what's f? Plus fc times tau. All right. what is
Don't
h of
don't we have a
omega.
minus sign?
Yeah, don't we have a minus sign up there?
Oops, yeah, thank you. Which is going to be, in this case, all right, so this is on the discrete time frequency, right? In this case, we just use the formula. Because it's band limited, I can just use the formula here. PTX, right, times omega. Right, and here, this is, okay, for this guy here. Because in this region, all right, omega's going from, again, omega's going from minus pi to pi. That means f is going minus 1 over 2 pi to 2 pi. So this guy here is,
That's not too.
right. A squared. Right, because in this region, alright, so I just put g of omega, right? Alright, sorry, this is right, this way. No, this way, this way. That's right. A squared. Vector of, does everyone see that this is just a squared? That PRX times PATX is, does everyone see that?
No. Where does
Okay.
A come from?
Okay, a squared.
Yep.
Okay, right, because in, okay, so actually, no, okay, let me write this here. For omega equal to f, right, for f, if omega is less than pi by 2, or less than pi, right, that implies that f, which is which is omega over 2 pi t, right, that has to be less than 1 over 2t. Because if omega at the maximum value is pi, I get the maximum value is pi, it'll be 1 over 2t. So that implies here that p Rx of f equals p Tx of f is equal to a. In this frequency range, because they're both a from minus 2. So it's almost always the case that these guys will just drop out. Right? So h of omega.
So if you just shift it, you always, so if you shift it, it'll be A times the shift. So it'll be a way easier way to do it than doing all this.
Wait, which one?
So by just shifting, it'll be a lot easier to get that
Correct.
times, okay.
Yeah. So it'll be a squared over t times g of omega, right? Oh, sorry, g of omega over 2 pi t. That is a squared times alpha times t times e to the minus j 2 pi. And then I have to substitute this f. So I have a 2 pi j f c times tau, right? And then I have a minus j 2 pi omega tau divided by 2 pi t. I think that is right. Does everyone agree with that formula? Because I just took my g of f is here, right? And I put f is equal to 2 omega over 2 pi t. I put it here, all right? This is equal to a squared alpha over t. All right. Yeah. The 2 pi's cancel out. Like this. Okay. Note the only dependence, this here is all like, doesn't depend on, this all doesn't depend on omega. So we want to B. We're going to do part B now?
Yeah.
Of this? Okay. Yeah, part B, all right. What it is. Okay. So this here, we have to take the inverse transform of this, all right? So let's just take a look at this. Now, h of omega, in this case, all right, will be a squared times alpha divided by t times e to the minus 2 pi j fc times tau. Now, all of this guy, I'm going to write some constant c, which is, it doesn't depend on omega. All right, because this is a trick. So just some constant, and then this part here, I'm going to say put omega. I'm going to take tau is equal to LT. That'll be minus j omega L. Right. So it's just c times e to the minus j omega L. Okay. Now, what is the inverse DTFT of that?
It's just shifted. So it's
Yeah, it's just h of k. All right, that just h of k is equal to delta of k minus L. All right.
multiplied by 0.
Right, because it just gets shifted. O times c. All right. So in other words, that means r of n is what in terms of S of n?
Professor, what's
Yeah.
L?
So just for some L.
Oh, okay, so,
Just a constant.
Right, just integer constant. So basically, if the delay in the channel, or if the delay is an integer number of delays of symbol periods, it'll just result in an integer number of symbol delays here. Yeah, what he's lost. No,
Like
you got it. Okay.
the last step.
Oh, how do I get from here to here?
Yeah.
Oh, because, okay, what happens when I remember that R of n, all right, is the sum over k of hk times s of n minus k. But this is only has a value at a k equals L. At k equals L, at c, and all the other values is 0. So that's just going to be c times s of n minus L. So the upshot of this is let's actually look what really happened. In the passband channel, all right, the channel was actually delaying this by L symbol periods. Now, interestingly, remember a delay in passband is also a delay in baseband, but with a phase rotation. All right, but it's still the same delay. Then when we compute the effective digital channel, a delay in the a delay which is an exact integer number of symbol periods in the baseband will correspond to a integer number of delays in the discrete time channel. All right, but we still have this C which has this phase rotation due to the delay, the carrier frequency. All right, so this is like putting all this stuff together. All right, but it's not that easy. Okay, so should we go on to homework 8 or 9?
Yeah.
Okay, so which one do you guys want to do?
8.
8, okay. When did I say homework 8 is due?
Sunday.
Okay.
on the 8th.